morning, all of you. Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, located at Hyderabad. Today, we are going to study the classification of kinematic pairs. Before lecture, we have studied what is kinematic pairs, and first classification of kinematic pairs we have studied. But in this lecture, we are going to study the complete classification of kinematic pairs in this lecture. What is kinematic pair? So in this lecture, we are going to study the classification of kinematic pairs completely. A kinematic pair is nothing but a pair is a joint of having two links having relative motion between them. So the pair we are always discussing about here only about pairs. Pairs means joint of two links. So in a slider crank mechanism, we are going to show in this figure example of what is kinematic pairs and all. But what is types of kinematic pairs? The types, there are three types are there. All kinematic pairs are classified based on three categories. Number one, nature of contact between the links. Number two, nature of mechanical constraint. And number three, nature of relative motion between the links. So links means here pair. What is a pair? That the two links joined at the joint. The motion between the two links based on the motion, based on the relative motion. In overall view, based on how the nature, how the behavior between the links. The behavior is number one, it is the contact. Number two, it is mechanically constrained, and three, relative motions. So in the previous lecture, we have studied in detail about nature of contact kinematic pairs. Let us give a glance. So based on the nature of contact, there are two types are there. Number one, lower pairs. And number two, higher pairs. What is the lower pairs and what is the higher pairs? The lower pairs means the relation between the two links. The contact between the two links is either surface contact or area contact. The examples for this lower pairs are nut turning on a screw, shaft rotating in a bearing, all pairs of slider crank mechanism and universal joint. And higher pairs. Higher pairs, the contact between the two links is either point contact or line contact. Okay, happens between common followers. So either point contact or line contact. So both the things can never be happens among the links. That is very important. It can become either line contact or point contact. The combination of these two doesn't happen at the same time. Similarly, the contact between two links, either is surface contact or area contact, doesn't happen the combination at a time. It happens only at contact once a time. Suppose surface contact is some period of time, and after that area contact between them will be another certain period of time. But both contacts doesn't happen between the links. Now examples for lower pairs. Let us see here is a nut turning on a screw. You can glance how the nut is contact. His surface is contact with the screw thread on a bolt. This is the combination of sliding pairs also and rotating in a bearing. So there is different contacts are here and in this portion, and here it is sliding. It is a surface contact. And it is a lower pairs. The contact is the slider crank mechanism. Here you can see the contact between the links. Suppose link 1, 2, 3, 4 slider and fixed link. And it is also slider crank mechanism. Just give a glance. In the last class I already covered in detail. You can go through it. These are universal joint, how they contact. This is also universal joint. There are different, how the, here in this figure, but purposefully I am showing here, this figure indicates how the various angles of motions can be transformed from one shaft to another with the different angles. Now coming to higher pairs, the higher pair, when a pair is having a line contact between the links, it is known as higher pairs. The contact surfaces between them links are not similar, it is dissimilar. Whereas in lower pairs, it is similar. So surface contact on the two parts, it will be equal. So what are the examples are? The examples is the surface contact in the lower pairs, this hand and this hand both, when these contact each other, how much this hand is experiencing the contact of the second hand lower hand can be experiencing same contact with the upper hand. That's why it is the contact between the two surfaces are similar, or two links are similar in the case of lower pairs. Now the examples for lower pairs are wheel rolling on a surface, cam and follower pair, tooth gears, ball and roller bearings. So all these examples I'll show you in animation views. Let us see. So here it is wheel rolling on a surface. The contact, the below smaller wheel is having a line contact, and here it is the geometry of tire is entirely different. That's why it is the point contact between this road and the wheel and the tire. And the road and the tire, here it is the design of the tire, it depends. So it is a line contact. And between cam and followers, I'm going to show you various followers. Here roller follower in detail explained. Once again I'm reminding that in before lecture in detail what are the types of followers which we are going to study in the module 4. So is the spherical roller pair, the roller follower, the top part, the follower is the certain angle of the cam, it will raise the follower. That's called angle of rise. And at certain angle of the cam, there is no effect on the motion of follower. That is called angle of dwell. At certain angular portion of the cam, rotation of the cam, the follower comes down. That is angle of falling. So these are the three divisions will be there in relation to the angle of motion of the cam and the angle of rising of the follower. The motion of the follower and the rotary motion of the cam. These are the three terminologies we are going to use in drawing the cam profiles. Cam profile means it is the shape of the cam we are going to draw based on the motion of the follower and the angle of rotation of the cam. That diagram is called cam diagram, also design of the cam or cam profile. So just revision, what will happen here, the follower having different motions, it can become a uniform velocity motion, and it can become a uniform acceleration, and retardation. The follower can also have the motion of simple harmonic motion, SHM, simple harmonic motion. So combination of these two also can be happen. Suppose the angle of rise, different combinations of angle of the motion of the follower, we have to draw the cam diagram. The case studies can become during angle of rise, it can become SHM, and during angle of dwell remains the same, and angle of fall can become uniform velocity, or vice versa. During angle of rise, uniform velocity, and angle of fall can become simple harmonic motion. And also uniform angle of fall can be can become uniform acceleration or retardation, or angle of rise can become simple harmonic motion. So at various combinations of the follower, we have to draw the cam profile. That this complete methodology and what is the procedure, everything will be studied in coming lectures that comes under the syllabus of module 4. Module 4 in detail we'll study. So here our main focus is the contact between two links or two elements. Here link 1 is the cam, link 2 is the follower. The contact between these two is point contact. So that's why point contact, that's why it is called, it comes under the category of higher pace. This is also roller follower, how the contact between the cam and the follower is the point contact, is the knife edge follower, point contact. It is flat faced follower, also point contact. Even though follower, the shape, geometry of the follower is flat face, but it is in contact with the circular geometry, that is cam profile, cam. So when any type of geometry, when it is in touch with the curved surface, definitely it comes under the category of higher pace, and the contact between them is point contact. So let us see, these are the contact between two gears, like the spur gear. The spur gear having the teeth, based on the geometry of the teeth, the gears are classified into 6 categories: spur gear, herringbone gear, bevel gear, worm gear, rack and pinion gear, and internal gear. So here it is in the spur gear, we can see the teeth geometry, and in the case of herringbone gears, you can see the teeth are inclined, not a straight one. In the case of bevel gears, you can see the axis between the two shafts are not parallel with some angle. Here the axis between the two input power output both are parallel. Similarly, in the case of worm gears also, when it is in contact with another worm gear, the axis remains parallel. So if you want to transfer motion to parallel shafts, the spur gears and herringbone gears will be used. And the friction between in the case of the torque transmission, in the case of herringbone gears are higher in comparison to other gears. Now worm gears, you see WORM, worm gears, this axis, this is another axis. How the power torque is transmitted in different directions. Now here it is, both are again perpendicular. But the rotary motion, in the case of rack and pinion gear, the rotary motion is converted to reciprocatory motion. See, as we have studied, the rotary motion is converted to reciprocatory motion in the case of slider crank mechanism. Let us see in the case of slider crank mechanism. Yes, in this also mechanism also the rotary motion is converted to reciprocatory motion, but the application is different. There, in the case of the gears, we have to transmit the motion, we have to transmit the power directly. It is in direct contact. So the perpendicular, rotary show to reciprocatory. And here it is internal gear, type of gear is internal gear. It converts the rotary motion completely. Okay, rotary motion to rotary, torque will be transmitted. So based on the requirement, we are going to use more torque. Among all these gears, the coefficient of friction is very high. In the case of herringbone gear, the coefficient of friction is higher in comparison to all other gears. Alright, so let us see, mainly focusing on the contact between the two elements. Just to give a glance, it is the point contact. These are all comes under the category of higher pace. Examples. So this is rack and pinion. You can understand here how the power will be transmitted. Rotary motion is converted into reciprocatory motion. These are internal gears. Now it is the between ball and roller bearings. This is the ball bearing example. In this ball bearings, how the power is transmitted, and the contact between the balls. These are the balls, steel balls, and the inner ray, outer rays is a point contact. It is a double point contact examples. Yet there are two. At the inner rays, one point contact. The upper rays, another point contact. Okay, that's why it is comes under the category of higher pairs. It is a lower pairs, lower bearing. Yeah. Now, so far we covered based on the nature of the contact between two links. So we studied higher pairs and lower pairs with detailed animated examples for understanding better. Now coming to second category, the second category is that closed pair. There are two types are there. It is based on nature of constraint, mechanical constraint. Here mechanically constrained means we are restricting the motion of one link to another link. Between the links it is completely constrained motion. No matter how much force you apply, it comes under the category of completely constrained motion. So here there are two types of pairs are there. Number one, closed pair, and number two, it is unclosed pair or open pairs. So closed pairs means, you understand here, closed pairs here between the two elements. It is an example of figure 1.7a. You can see that it is a closed pair. So let us read what it is defined completely here mentioned. When the elements of a pair are held together mechanically, it is known as a closed pair. So the two elements are geometrically identical. The two elements are geometrically identical. One is solid and full, and the other is hollow or open. So the latter not only envelopes the former but also encloses it. It should be completely closed one, enclosed. The contact between the two can be broken only by destruction of at least one of the members. If one of the members is broken, then the contact will be vanished. But one element will be completely closed by another element. So what is geometrically similar, identical means the diameter of the cam here is same as the length, whatever geometry it is remains same. Then only contact takes place, otherwise there is no contact. That's what mentioned here. Now all the lower pairs and some of the higher pairs comes under the category of this pairs, closed pair. So all the lower pairs means we study here when surface contact or point contact it can become. In the classification of closed pairs, again in this class it will again fit into some of the lower pairs can be used, can be called as closed pairs, and some of higher pairs can also be called as this closed pairs. Now what are the examples? This type of closed pair is called, here it is a screw pair, okay, and cam and follower pair also. When the cam and follower pairs, what happens? Cam and follower pairs also, okay, screw pairs, and also one more is called, comes under the category of this closed pairs. Now one more is that, what are the examples? Now coming to the definition of open pairs. What is the open pair here? The cam and follower. We have studied cam and followers contact is higher pairs, comes under the category of higher pairs. But here we are discussing about the classification about unclosed pairs or open pairs. Now when the two links of a pair are in contact, either due to gravity or spring force, they constitute, what will happen? They constitute as a they constitute as a open pair. But the contact, it can become either point contact or surface contact. We can also say that in this category, some of the lower pairs also can come into this category, and some of higher pairs also can be considered into this category. So in this, the links are not held together mechanically. So it is not held together mechanically, but it can be either gravity or spring. But we are not mechanically, means with some external force. With some external force, as we have studied. That means, as we studied in types of constant motion, that is third category, successfully constant motion. In successfully constant motion, what will happening? The shaft is held together, is under the motion. It is under the motion when it is applied force. Otherwise, it is under category without applied force. What happens? The shaft can be come out because of the force which will act on that. Alright. Now, by applying external load, this shaft can be completely constrained. Otherwise, it is in complete constant motion. So, but the contact between the two is which contact? Line contact. That's why it is a higher pair contact here. Okay. Thus, some of the pairs, we can use some lower pairs also, some of higher pairs also can be classified, can be fit into these two types, are closed pairs and higher pairs. Higher pairs and closed pairs can become into the category of this closed pairs and unclosed pairs category. Alright. Now, this is second type of kinematic pairs classification. Now coming to, this is closed pairs as I discussed in detail. Now we can see unclosed pairs motion. In this animation you see how it is. The spring is, the cam and follower is moving. The cam is moving in clockwise direction and follower is moving up and down. The follower is rising at some angle of the rotation of the cam. The follower will be raised. That is called angle of rise of a cam. And at a certain angle portion, this is the portion, there is a constant radius, that is called angle of dwell. There is no motion in follower. That is angle of dwell. And here it is at another angle of portion. What is happening? The follower is coming down. That is called angle of fall of the cam. Now in this case, we can divide it. If it is rotating, so this angle is angle of dwell. This portion is angle of dwell. And this portion, what is happening? This portion is angle of rise, theta r, angle of rise, and remaining portion is angle of fall. So theta r is angle of rise, theta d is angle of dwell, and theta f is angle of fall. Thus, these are the three categories terminology we are going to use in the case of cam profiles. Next, this is the third classification of kinematic pairs. So here kinematic pairs are classified based on according to relative motion between the links. So we will see here how to remember also in order. I'm going to discuss how to remember them in order. Now here there are different types are there. It is a sliding pair, and second one is turning pair. It is sliding pair, and next one is a turning pair. So next one also there, screw pairs, this called roller pair, and it is a screw pair, and it is a spherical pair. There are total 5 types are there for or comes under the categories of kinematic pairs based on relative motion. Now what is the sliding pair? Number one, all of you remember, first itself in the initial I am telling you, you remember ST, R, S, S. These are the 5. What is S for here? Sliding pair. Sliding pair. T, turning pair. What is R? Rolling pair. What is S? Screw pair. What is another S? This is spherical pair. STRSS. STRSS. You remember all of you, so that you can write in examination without any deviating the order. STRSS. Where is first S for sliding pair? What is a sliding pair? If two links have a sliding motion between them, it comes under the category of sliding pair. The relative motion is sliding. Now it is called sliding pair. Here there is the link 1 and link 2. We also studied this sliding pairs also comes under the category of completely constrained motion. Again, if you see types of constrained motions, there it comes under the category of completely constrained motions, sliding pair. So a rectangular rod in a rectangular hole, a rectangular rod in a rectangular hole in a prism, then it comes under sliding pair. And figure B, if you understand, it is figure B is what? It is a turning pair. This turning pair, what is that? It is rotating, revolving pair. It is also the relative motion between the links is a turning or revolution or revolving motion. Revolving motion relative to the between them. Then they constitute what? Turning pair or revolving pair. So this revolving pair is also, that comes under the category of completely constrained motions. So sliding pair and turning pair comes under the category of completely constrained motion. And now if we correlate or if we observe in relation to nature of contact of kinematic pairs classification, this is the sliding, this is the surface contact. Here also it is completely, this is also surface contact. So either surface contact or area contact, those pairs comes under the category of lower pairs. So these are all correlation. So here this pair comes under the category of completely constrained motion and also sliding pair, okay, and also lower contact, lower pair. So like that, each links, each pair can be considered or can come into various classification. Okay. Now second type of kinematic pair is a turning pair. The turning pair means what? The links, turning motion. What is the turning? Means revolving motion. That revolving motion having relative motion between them, then it is called a turning pair. That when the link, if two links have a revolving or turning motion relative to each other or between them, then that pair comes under the category of what? Turning pair. So turning pair example is that a revolving shaft. A shaft is rotating, revolutionary motion inside a bearing. Then it comes under the category of turning pair. Now it is a sliding pair example. How the sliding pair? You can see the sliding pair comes under the category of, as I told you before, is the lower pair contact and also it is a sliding pair. Which is a sliding pair? The cylinder, the piston, the slider is moving inside the cylinder. Then it is a sliding pair. Alright? That is the way you have to understand. Now, coming to third category, rolling pair. So far, as I told you, S, T, R, S, S. We studied S and T, sliding pair and turning pair. Now, coming to the category of rolling pair. What is the rolling pair? When the two links have a rolling motion between them or related to each other, then it comes under the category of rolling pair. So here the examples of rolling pair is very important, is that when the rolling pair is, example is that we already discussed roller bearing or ball bearing. So ball and roller bearings comes under the category of these rolling pairs. Let us see how the ball bearings are moving. Yeah, we can see in the case of this roller bearing, so this roller pairs based on the relative motion comes under the category of, also under the category of higher pairs. Why? Because it is the line contact between them. Is the ball bearing had double point contact. So here double line contact. There will be inner race and outer race. This is outer race and inner race. So the point is that the contact between them. So all roller pairs are called as higher pairs. Okay. Now fourth one is screw pair or helical pair. The screw pair or helical pair, if two mating parts or the relative motion between the two links is turning motion or sliding. Turning, it should have both the two things. One is a turning, there are two motion, turning and sliding will be taken place. Then it comes under the category of a screw pair. So this motion will be happen. What will happen? This type of motion can be observed when in case of lathe machine, the lead screw, motion of the lead screw inside the nut of a lathe machine comes under the category of the screw pair. The motion, the screw pair can be observed. We can see clearly. So when screw is moving, automatically this slider and this slider will be there. Slider means what is that? Apron. It will move. Okay. The rotary motion is converted. The rotary motion of the screw is converted to reciprocatory motion of the tool post. The tool can be moved because of this motion, this lead screw. So that comes under, the mechanism is very simple. We also observed this one, lower pairs category. Lower pairs category, in the case of lower pairs category, yes, the lead screw principle, this is how the lead screw is moving. Okay, that is called as screw pairs. Okay, this is also screw pair. You can see how the lead screw, when the screw moves, the motion moves, it's both the rotation and also sliding takes place at the same time in the case of screw pair. Okay, now the next category is, what is the next category? The next category is what? Spherical pair. What is happening in spherical pair? In the spherical pair, when one link in the form of a sphere turns inside a fixed link, it is a spherical pair. So the ball and socket joint is a spherical pair. This type of spherical pair, the spherical pair can be seen where in case of on two-wheeler side mirror will be there. And not only two-wheeler, four-wheelers also. In side mirror, having a mirror with the joint. The mirror, if you see side mirror, having at the end, in the case of this sphere. Okay. The mirror can be adjustable in different directions, at the same time rotations. This, because of the spherical pair only, it will happen. Not only that spherical pair, you can see the spherical pair in the case of tractors. where tractors are used for plowing the agricultural fields, where you can see when the tractor backside is connected with the, for plowing purpose, one attachment will be there. That attachment is joined to the engine of the tractor with the help of ball and socket, the spherical pair only. It can be moved, because when the tractor is moving, it has to plow the fields. So the joint between tractor and also this plowing machine, whatever using attachment to the tractor, that is having ball, the spherical pairs. So the spherical pairs are very important for transmitting purpose or for joining purpose. Okay, very highly important in the case of mechanical engineering. So this is the example for screw pairs. Okay, so far in this class we have studied the examples of various mechanisms, how it will be useful. Okay, and in this class, okay, how the classification of kinematic pairs based on nature of contact. Again, nature of contact is divided into two types. That is nature of higher pairs and lower pairs, and nature of mechanical constraint. In the nature of mechanical constraint, open pair and closed pair, and based on nature of relative motion, sliding pair, turning pair, rolling pair, screw pair, and spherical pair. So just thank you all of you, but just to give a glance completely how the classification of kinematic pairs took place in this slide, how the complete summary of classification of kinematic pairs. If you remember this slide, classification of kinematic pairs, just one slide make you to understand complete. At our institute where I am working, it comes into the end examination with the 7 marks. So end semester examinations, first category is mechanical contact, nature of contact. Second one is mechanical constraint. And here, if you see here, based on nature of relative motion. Again, nature of contact, there are two types are there. Number one, higher pairs, and two, lower pairs. And nature of mechanical constraint, again two types. One is closed pairs, another one is unclosed pair or open pair. Nature of relative motion, there are 5 types. Sliding pair, turning pair, rolling pair, screw pair, and finally spherical pair. So total under nature of contact there are 2 types. Nature of mechanical constraint there are 2. Under nature of relative motion there are 5 types. So this nature of relative motion we can remember STRSS. You remember this only one word, that is STRSS comes under the relative motion category. So this is complete classification of kinematic pairs. Very important question for examination point of view and also public sector examinations. So if you remember this one slide, that's it enough for you to attempt this question in end semester examinations. Thank you.
Like, share and subscribe. hit the bell icon for more updates.